Hello and welcome once again. In this video, I will be discussing the solutions for the weekend contest 84. So there were 4 questions and we will try to solve each of these 4 questions with a detailed explanation, and let's move forward to the solutions. So coming to our very first problem, which is called as nines. So this problem is not very difficult. As you can see, it has been rated as easy. So this problem says that you are given an array A of length n consisting of single digit numbers. You are a fan of the number 9, so you want to select a subsequence of length k consisting only of the number 9. Okay. Return 1 if it is possible to select such a subsequence, and return 0 otherwise. A subsequence is an array a subsequence of an array is a sequence of elements that can be obtained by deleting some elements from the array. Okay, so here we have k value equal to 2, and we see the value of a is equal to 19239. It has two nines, so therefore at least two nines are existing, so a subsequence is possible, therefore I should print 1. Alright, so basically what we have to do is we have to calculate the number of nines that are present in the given array. If the value of nines is actually greater than or less than equal to 2, less than equal to k in this case, then we have our answer. Alright, let's start writing the code. So it's going to be something like this. Now that I have this function written for me, public static int nines, int n, int a, and int k, where a is my array. Alright, so what I'll write is I'll create a variable called as 9 count, and I'll initialize it to be 0. After this, I will write a for loop for every element inside a, which is my array a. Inside this, I will write if I is equal to 9. If I is equal to 9, the 9 count will increase by 1. Alright, if I is equal to 9, then 9 count will increase by 1. Then I will check if 9 count is actually greater than equal to k. If yes, then I'll return 1. Otherwise, I'll return 0. Return 0. Alright, so this should be my code. Let me try to run it. Upon running it, we see that, let's wait for the compilation check. We can see that all the test cases have successfully passed. That's great. Let's click on submit. Once I click on submit, you can see that there's compilation check, large test case check, and optimal code test check. And yep, I think that it basically was correct. Great. So we did pass all the 11 out of 11 test cases. That is great. Let's move to the next question. So now we have the second problem. The second problem is called as generation gap. It says, suppose we have an array A that represents a family tree where each element AI represents the parent of the ith individual. Okay. How far apart are the first and last members in a family tree? Well, not very difficult. So basically the thing that we have to note is this part, that every element inside the array, that is AI, is representing the parent of the ith individual. Fine. So that is understood. Let's try to calculate the distance. So like in this case also, you can see after following this condition that if each element AI is representing the parent of the ith individual, for this array, yes, we can see that 2 is the child of 1. Okay, the other 2 is the child of 1, fine. 1 is the child of 2, and then 3 is also the child of 1. Okay, great. Then 4 is actually the child of 2. Nice. Okay, so yes, we can see this kind of binary tree getting created. Nice. Now this is our binary tree, and then we have to find the like how far are the last and first members, that is 5 and 1, which is equal to 3. So 4, 2, and 1. Great. Now we can easily solve this question, not very difficult. So the idea that is in my head is this, that we will start from the last member of this entire, we'll start from the last member that is given to us. Okay, last member of the family, which is 5 in this case. Okay, and for every member we will go to its parent, and then its parent, and so on, something like depth first search. Okay, so we will keep on traversing parent by parent by parent, so that until we reach the first parent, that is the root of the binary tree. Once that happens, then we will have the distance. So it's basically going to be that only. So it's not very difficult. Let's try to do that. What I will write int distance is equals to 0. Okay, then I will write n is equal to n minus 2. Why? Here the value of n is actually the number of elements that are going to be there. So as you can see that there are 5, n's value is 5, which means that there are 5 members in the family. But I am writing n equals n minus 2 so that this entire array, as you can see, its length is equal to 4, right? Its length is equal to 4. To access all the elements of the array, I have to traverse from 0 to 3, which is why I am writing n minus 2, so that whatever value of n I have, in order to traverse my entire array, I am making it 0 indexed, which is why I am subtracting the value 2. Now it's simple. I will write while loop, while n is not equal to minus 1. That means as long as n is actually positive. So as long as n is actually positive, because we're starting from the last member, I will write n is equals to an minus 2. This why? Because we know that the parent of this thing is actually this thing, and I'm writing minus 2 for the adjustment to 0 index. If this happens, then I will increase the distance by 1, distance plus plus, and lastly I will return the answer. So return the distance. Let's try to see if it is correct. Click on run. After clicking on run, we can see that all the test cases have successfully passed. That is great. Then I will click on submit. Let's wait for the moment of truth. It says compilation check is great. Large test case check is also fine. Optimal test is also correct. Great. So on the basis of this, so this is the code that we will be noticing, which is going to tell us what is going to be the distance between the first and last node. All right. So this was the second question's solution. Now we will move towards the third question, where we will be discussing the solution to the third question. All right. So now we can see the third question on my screen. The third question says that you have an array A of length n. You have to divide the array into at most m consecutive segments. Okay, the maximum segment count is m, such that the maximum bitwise OR of these segments is minimum. Oh, okay. It is a maximization minimization problem in which we have to minimize the maximum of bitwise ORs for the at most m segments that we are going to create. Return the minimum possible maximum bitwise OR of these segments if you divide them optimally. For example, let n equals 5, m equals 2, where m is the number of segments that can exist, and they have to be consecutive as well, okay? And then a value is equal to 15244, okay? We can divide a into two parts, 15 and 244, because the bitwise OR of both of these segments is going to be 5 and 6 respectively. Both of these segments is 5 and 6 respectively, so our answer is 6, which is the maximum possible. One second, consider says the maximum bitwise OR of these segments is minimum. Okay, so the bitwise OR of these segments is 5 and 6. All right, so this is 5 and 6. Okay, so our answer is 6, which is the minimum possible. Fine. Okay, so what we have to do is that every time we create a segment, or we can say that we have the right to create at most m segments. That is written over here. After creating m segments, what I will do is we have to calculate the bitwise OR of these segments. After calculating the bitwise OR of these segments, I have to find out which is the maximum one, and then I have to find the minimum maximums that are possible. That is what we have to do. Okay, so that is what we are going to do. That is what we are going to solve. So the idea which is in my head is coming towards binary search, because if you look at constraints of this question are present over, let me see, constraints. Okay, I can't see a constraints. Well, that's okay. Yeah, here it is. Fine. So this is the constraint. So as you can see, the value for n is actually very high, and the value for ai is also actually very high. The sum of n overall test cases does not exist, 10 to the power 5. Okay, fine. So what it is basically suggesting, and you can see the time limit is also 1 second. So I think that we can go ahead with the idea of binary approach, that is dividing the whole segment into two parts and then searching for the right answer in one part, and so on and on. Okay, so in my head, binary search is definitely coming into picture. So for any value of the array, let's call it x. If there is any value of an array, let's call it x. And if we try to search it in, or like put it inside the R function, which is going to do something like a binary search, then we will check if that value which we are passing is the answer, just like we check the middle element. If it is our answer, then great. If not, then we will do something else. Then we will check for less than or greater than, right? So what we will do is that for breaking inside a normal binary search, we would break the entire array on into two parts on the basis of the element being greater than or lesser than the middle element. That is what we do in terms of binary search. But here, the purpose on which we are going to break the segments is going to change. We will break the segments whenever the bitwise OR of the element that we are getting, bitwise OR is of the element that we are getting is actually greater than the element that we are passing. So bitwise, first of all, what I'm trying to say is that once we pass the element, or like suppose if it are iterating over the array segment, and if we are trying to calculate its bitwise OR, after that we will check if whatever element we have passed, if the element is actually greater than or lesser than, let's say the element is greater than the bitwise OR, in that case we have to increase the count of segments. Okay, otherwise we will not increase the count of segments. Okay, so that is how it is going to be. So let us go ahead and try to write a solution for this. Okay, so what I will do is, we already have this static function, so I'll write public static long optimal division, and I'll create a helper function also. So public static boolean optimal division helper, and I will pass a few things: long middle element or mid, int n, int number of segments, and lastly the array. These are the four things that I will pass. All right, so here mid element is basically any element of the array, yeah, that we will basically find, and so on and on. That is what we are going to do. So I will start with starting my, or like calculating the OR value, bitwise OR. So I'll write int value after OR is equals to, let's start with 0, and int current count of segments, current count of segments 1. All right, so initially we will decide that okay, one segment will exist. Then I will write int I is equals to 0, and I will start iterating over the array. So well, I is less than n, okay, followed by I plus plus over here, and now all the code will be written like this. Okay, so now here I will write my first condition: if the array I is greater than middle element. If this is the case, then there is no segment possible, so I'll write return false. All right, otherwise I will start to do the OR operation. So value after OR is equals to, or I can write OR equals array I, which means that I'm trying to do the OR operation between two elements. All right, so after doing the OR, I will check again. So I'll write if value after OR, one second, if value after OR is greater than middle element. If this is the condition, then in that case, value after OR will become 0 for resetting it, and I will increase the segment count right over here. So count of segments is going to be increasing by 1. And lastly, because it was increased over here, it should rerun the loop over in the same index one more time. And lastly, I'll write return current count of segments is less than equal to number of segments. And that's it. So this is going to be my helper function. So what it basically means is that it is going to return a boolean value, true or false. If the value is actually going to be true, then in that case, we will divide on the right hand side. Otherwise, we will try to, if the value is actually true, that means we will try to divide on the left hand side. Otherwise, we'll try to divide on the right hand side. So let's try to see how this is going to work. Here I will write, let's say int n is equals to a dot length. Then I will write long answer is equals to a very large value. I mean, you can take any large value. I'm just taking a large value like this. Then I will write long left is equals to 1, and then long right is equals to, say, any large value. So long 1e10. Okay, 1e10 means 1 raised to the power 10. Now I will write a while loop. While left is smaller than right In that case, I'll write the middle value. So long middle element is equals to left plus right by 2. Okay. Now I'll check if optimal division helper, middle element is going to be mid only, n is going to be n, number of segments that we have is m, and the array is a. Okay, if this condition is true, that means more segments will exist. Then in that case, I'll try to basically move my answer towards the left hand side. So I'll write answer is equals to middle element, and then right is going to be middle minus 1. And then I'll write a else condition. I'll write left equals middle plus 1. That's it. And lastly, I will write return answer. Okay, let's try to run this. Running this code, we can see that all the test cases have been successfully completed. If I click on submit, after clicking on submit, we can see compilation check is fine, large test case check is also fine, and we can see that the answer is also correct. All the test cases are passing. So this is your solution. Okay, this is your solution, as you can see. Okay, so this is your solution for our third question, which is the optimal division. Now let's move to the last question of the contest, which is called as lucky sum. This question is slightly more difficult, so even I'm not sure if I'm going to solve it, but I'll try. So this is the last problem. It says Alex, okay, it's rated as hard. It says Alex has a set of n distinct numbers. He wants to select any non-empty subset of the numbers. But his friend Bob is interested in the divisibility of the sum of the subset. Bob calls the subset of chosen numbers lucky if the sum of the subset is divisible by k. Return the probability that the subset chosen by Alex is lucky. The answer should be found modulo 10 raised to the power 9 plus 7. Formally, let m equals this. It can be shown that the answer can be expressed as an irreducible fraction p by q, where p and q are integers and q is not equal to 0. Okay, mod m, all right. Output the integer equal to p multiplied by q raised to the power minus 1. Okay, mod m. Interesting. In other words, output such an integer x that x is between 0 and m, and x multiplied by q equals to p mod m. Alright, this is going to be interesting. So this question is actually very interesting. We have to basically select a subarray or subsequence whose sum is divisible by k, alright, from the array A that is present over here. So what we are going to do is, we know that the values of the array, if you look at the constraints, the value of k can be as high as 10 to the power 16. So because this value is very high, if we have to think of a method to actually reduce the time complexity, even if we do dynamic programming, it's going to be too high because the size of k is very, very large. Okay, then brute force is not at all an option because the value of n, which is going to be 40, that will become very, very high. So brute force is not an option at all. If this value was like 5, 6, 7, 8, 9, 10, it would have been still possible. So what if we try to do something like this? What if we divide this entire array of A into two parts? Okay, we'll try to divide this array into two parts. And what we will do is, after dividing into two parts, we will try to apply brute force on the, let's say, one of these parts, let's say first part. And we will try to calculate the frequency of every element that is present inside the subset. Okay, so that is what we will try to find. Frequency of each value of subset minus sum modulo k. Suppose we'll do that, okay, because we have to do modulo k every time according to the question. So let's try to do that. Okay, let's try to do that. So what we will do is that we will try to store from the first subset, we will try to basically calculate the subset value minus sum inside the modulo with the modulo of k inside a hash map. We'll do that. Now we will apply the brute force on second half of elements, and we will try to calculate subset minus some x and add it to the frequency of subset minus some k. Something will basically apply some mathematics over here, and after adding the mathematics, we will have two subset sums which are, when created, they make the subset divisible to k. Something like that is what I'm thinking. So let's try to do one by one. Okay, let's try to do one by one. So we will start with let's start with the easier part. Let's try to do the first part and second part first. Okay, so we'll try to deal with the first part and we'll try to calculate the frequency. Let's start there. Okay, so we'll do it part by part because I think the solution is going to be very, very large. So as you can see in the question, it says the answer should be found modulo 10 raised to the power 9 plus 7. So I'll write long modulo or mod is equals to log of 1 e9 plus 7. That's given in the question, which is why I'm writing it. Okay, so this is going to be my mod value. Then I'll have to get the first part. So int first part is equals to n by 2. All right, simple. Then I'll create my map. So do I have java dot? This is going to be from java.util. So I'll have to import it. Import java.util. Basically, I'm creating a map. So I'll write long, comma long. I'll call it frequency map. Frequency map is equals to new hash map. New hash map. Okay, so after writing this much, what I will do is I'll try to iterate inside this. So int I is equals to 0, I less than 1 left shift first part I plus plus. Now what is the reason that I have written the loop like this? What is the reason that I have written the loop like this? Well, the reason why I have written the loop like this is because I want to run my loop from 0 to I equal to 2 raised to the power of first part. That is why. So in order to get 2 raised to the power of first part, I can just do left shift, which is why I've written it like this. So left shift is actually very much faster in order to calculate powers in 2 because it's a binary number. So that's why I've written it like this. Okay, so now that this is done, what I will do is I will write the sum. So long sum is equals to 0. Then I'll write another loop for int j is equals to 0. J is less than first part, and then j plus plus. Okay, here I will write if I right shift of j is equal to 1, then in that case we are going to increase the sum. Sum plus equals a j. Okay, this is what I will write. After that, do we need any more things in? No. So this for loop is over. And then lastly, before ending this for loop, I will write frequency map dot put sum mod k is frequency map dot get or default sum mod k followed by the default value as 0 as long plus 1. So what am I doing over here? It's not very difficult if you look at it. So initially I'm running a loop from I equal to 0 to I equal to 2 raised to the power of first part. Alright, that is what I'm doing. 2 raised to the power of first part minus 1 basically, because it is just less than. Okay. Now inside this, what I'm doing is I'm initializing a variable called as sum equal to 0. After that, what I'm doing next is I'm writing one more loop which is running from 0 to first part minus 1. If the jth bit of I is actually set, then in that case I'm adding the sum, or basically adding the sum. What I'm trying to check is that if jth bit of I is actually equal to 1, that is what I'm trying to check. Okay, so I'm trying to find the jth bit of I, and if it is actually set, that is why I'm trying to add it over here. Alright, so yep, that is what I'm doing. And lastly, whatever sum I got, I just added it to my frequency map. So this was the first part. Now let's try to do the second part. So I'll write int second part is equals to n minus first part. Here I'll write long. Now basically what am I supposed to do next? I have done the first part wala stuff, okay? I've done the stuff which was required in first part. Now I have to apply the brute force on second half of elements. On finding a subset minus sum, let's call it x, we will try to add the answer to the frequency of subset minus sum. So we are going to apply some mathematical formula in the first half of elements so that we can get our answer like that. Okay, so here I will start writing. So I'll write int, let's say numerator equals 0, and then I will write a loop. So for int I is equals to 0. Similarly, I is less than 1, left shift second part I plus plus. Okay, here I will write long sum just like the last time, long sum, and then again I will write a for loop. So for int j is equals to 0, j is less than second part, and j plus plus. After doing the second loop also I'll write if I right shift j and 1, that is logical, that is bitwise, and if it is equal to 1, then I will write sum plus equals a first part plus j, like this. After I'm done with this also, my second part is still not over yet. After writing this, I will write sum is going to be mod with k. Sum is going to be modded with k, and lastly I'll change the value for numerator. Numerator is equals to numerator plus equals frequency map dot get or default. Here it will be k minus sum mod k followed by 0 as my default element. Alright, so if I do not get it, I'll get 0 over here, and that will be added to my numerator. Once I'm done with this also, so basically what I'm doing over here, I'm running a loop over here. I'm running a loop over here from 0 to I raised to the power of second part minus 1. Then I'm calculating the value for sum, which is equal to 0. Then I'm running another loop from 0 to j equals to second part minus 1. That is what I'm doing over here. This is my second loop. And if jth bit of I is set, that means if jth bit of I is equal to 1, when I say it is equal to set, that means it's equal to 1. If it is unset, that means it's equal to 0. So if jth bit is equal to set, then in that case, I am writing, I'm adding the sum. Okay, I'm adding the sum. After that, I'm replacing the value of sum with the modulus with k, because that is required in the question. And then lastly, whatever frequency I have of k minus sum inside my frequency map, I am doing its mod with the numerator. I'm sorry, what I'm saying is that I'm trying to find out the frequency of k minus sum modulus with k from my frequency map. In case if that value is not found, I'm accepting it as 0, long value, and then whatever the value is achieved from getting this key's value or this value, I'm adding it to my numerator. After doing this also, I can say that my second part is also over. Okay, after doing this also, I can say my second part is also over. Now I have to decrease the numerator by 1 so that I can remove the count of empty set, because there can be a lot of sets, right? So one of the sets is going to be empty sets, so I'll write numerator minus equals 1. Okay, which is I'm reducing it by 1. Now I have to calculate its denominator value, so I'll write long denominator equals to 1l left shift of n minus 1. Okay, so the value or the reason why I've written it like this is because this is going to represent the total number of possibility of non-empty sets. So there can be multiple sets, right? We know that there can be multiple sets. It is going to be 2 raised to the power of n, which is why I have written 1 left shift n. But because one set is going to be empty, which is why I've reduced it with minus 1. All right, so this is the count of the sets which will be non-empty, or I should say this is the count of the subsets which will be non-empty. Now I have to calculate the GCD, that is greatest common divisor. So I'll write long GCD equals GCD numerator and denominator. Now I have to basically create this function. So let's create it. Public static int GCD. I'll write int numerator Is my numerator, yeah, it's an int value. Should I make it a long value? I think that will be better. I'll make it a long value. Okay, so I'll write long numerator, numerator, and long denominator. Or I can just write a and b. That's it. Alright, so let's calculate some GCD. GCD is an easy thing to calculate, nothing very complicated. So I'll write if b is equal to 0, then it will return a. Otherwise, recursively, I'll write return a. Otherwise, return GCD of b comma b mod, sorry, a mod b. This is my function for GCD. Alright, so now this function will be called over here. Okay, this function will be called over here. I think it should also return long only, long. Great. Alright, so this particular thing is going to be called over here. Now that I have my GCD done, now what I will do is I'll basically just change my numerator denominator values as and when necessary. So numerator is going to be divided by GCD, then denominator is also going to be divided by GCD. Then lastly, numerator percentage equals mod, and lastly denominator percentage equals mod, and lastly I'll write return, or I'll have to calculate my answer. Long answer is equals to numerator multiplied by power. I'll create this function denominator, then I'll pass mod minus 2 according to the question, because question is asking me that mod minus 2 mod with mod. Alright, the reason why I've written this is that this last line. Okay, so if you can see, output integer should be equal to p multiplied by q raised to the power minus 1 mod m. So that is what I'm trying to do over here. Okay, so this is my numerator and denominator, and then lastly, doing with this formula, I will get my answer like that. Okay, so now I have to create that last function. Also before this, I'll write return int answer. And here I will write public static long power. Let me just call it power. Here I'll write long a, long n, and then the mod value. So long mod val. Three things. Over here I will write long answer equals 1, then while n is greater than 0, I will write if n is n mod 2 is equal to 1, which is if it's an odd number, then in that case I will write answer equals answer multiplied by a mod value, mod val. Okay, if this condition is true, otherwise I'll write a equals a multiplied by a percentage mod value. Okay, lastly I will write n right shift equals 1. Alright, and then lastly I'll write return answer. Alright, great. So what I'm trying to do over here is, first we applied brute force on the first half of elements, as you can see over here. We tried to apply brute force on the first half of the element and tried to store the frequency of each value of subset sum mod k. Okay, subset sum, we try to calculate the subset sum, and then subset sum mod k, whatever value we got, we try to store its frequency inside the frequency map. After that, what we did, we tried to basically do the second, brute force on the second half as well. And after doing the second half brute force, whatever we are doing is, we will try to calculate subset sum x over here. So this is going to be my subset sum of the second half. And then I will try to add the answer, whatever I have got. Okay, whatever I have got as my answer, I will try to add the frequency of my subset, that is k minus the sum. Okay, because the value of k is given to me, k minus sum mod k, whatever value I will get from that, I will add it to my numerator in the first half of the elements. So after that, I'll add it to my numerator, as you can see over here. Now, now what happens is that the two subsets when added create a subset which is with the sum which is divisible by k. That is established. Now, we have to find the number of lucky subsets that are possible. To only count the number of non-empty subsets, we have to decrease the value by 1. That is what we have done. After this, the total number of non-empty subsets is going to be 2 raised to the power minus 1, which is why I've got this denominator. To get the probability modulo 10 raised to the power 9 plus 7, what we have to do is we have to use the modular arithmetic to divide the number of lucky non-empty subsets by total number of non-empty subsets. That is what we have to do. So in order to do that, I have to calculate my numerator and denominator and stuff like that. So this is the reason why I calculated the GCD of my numerator and denominator, and then I basically am trying to calculate the arithmetic. I should say that I'm basically trying to use the modular arithmetic to divide the numbers of non-empty subsets, which is equal to numerator, okay, by the total number of non-empty subsets, which is equal to denominator. So numerator will give me the total number of subsets that are possible, which are lucky, and denominator is basically the total number of subsets that are non-empty. Okay, that is what it is like. All right, so with this, we got our denominator and numerator values. Lastly, we have to basically make sure that the numerator and denominator are brought into their right formats. After bringing into their right formats, we are just calculating the answer with the help of this function. Okay, that is what we are doing. Let's try to run it. Okay, there's a problem. It says method power in class solution cannot be applied to given types. Let me see. It's a long value. Okay, actual argument list different in length. Okay, so I am passing 3 values over here, but here I'm passing only 2 values. Okay, so as you can see, the problem that is present in my question is actually present at this location. Okay, so this is the place where the problem is present. Let me just write it again. So I should write it like numerator, not like this, numerator multiplied by power multiplied by power. Lastly, I have to do the mod, right? So I'll do it over here, mod. Now here I will write denominator, comma mod minus 2, and then mod. Now let's try to run it. We can see that there are 4 wrong answers. Alright, there are 4 wrong answers, and when I click on submit, of course it will not work. So we have to identify some flaws inside our solution and try to fix them right now. So I just found out after going through a very thorough explanation of my code that I had basically made a mistake of putting an ampersand sign over here rather than putting a percentage sign. So if I put an ampersand sign again and if I click on run, you will see that the first 4 test cases will fail and only the 5th test case will pass, which is wrong. And if I replace it with a percentage sign and after that if I click on run, then you will see that it works with all the 5 test cases. So I'll click on submit. After clicking on submit, as we can see that compilation check is correct, and yep, we are able to see that all the test cases basically passed. So with this I can say that we are now clear with the solution of all the 4 problems that were put forward in the contest. Next thing is that I would really encourage all of you to take part in the contests that are getting live, and these contests will actually help you a lot in terms of interview preparation. So I really encourage you to go ahead and take part in the live contest which is going on right now, and I will see you in the next solutions video.